In question 7 of this exercise, we have to, on a squared sheet, draw two triangles of equal areas such that in part 1 the triangles are congruent and in part 2 the triangles are not congruent. What can you say about their perimeters? Well, the first part is actually quite easy. If you draw any two congruent triangles, by definition they will have the same areas because two congruent triangles are have the exact same shape and size. They can be superimposed over each other exactly. So any two congruent triangles will have equal areas. But in part 2 we have to draw two triangles that are not congruent but still have equal areas. Okay, so this one is slightly more complex than part 1. So let's do part 1 first. In part 1 we have to draw two triangles of equal areas such that the triangles are congruent. So let's draw any two congruent triangles. So let's take vertex A here, vertex B here, and vertex C here. Okay, so this is triangle ABC. Let's join the three sides, so ABC. And now let's draw a triangle which is triangle PQR, which is congruent to this triangle. So let me take the vertex P here and then vertex Q I take here. Okay, so I'm taking vertex Q at a position relative to vertex P comparable to what the relative position of vertex B with vertex A. Okay, so you can just see that the distance between A and B and the distance between P and Q is the same. Similarly, to take the vertex R, I observed that the distance between B and C I took was 5 units. So I will take vertex R here 5 units away from vertex Q horizontally. And now let's join PQR. So PQR. Okay, and now we can see that these two triangles are congruent. They have the exact same shape and size. So let's write the congruence relation. Triangle ABC is congruent to triangle PQR, and because of this congruence their areas must be the same. So area of triangle ABC must be equal to the area of triangle PQR. The other thing is that because these two triangles have the exact same shape and size, their sides are correspondingly equal. So AB is equal to PQ, BC is equal to QR, and AC is equal to PR. If you sum the three sides of one triangle, it will be equal to the sum of the three sides of the other triangle. And this basically means that the perimeter, so the perimeter of triangle ABC will be the same as the perimeter of triangle PQR. Okay, so this is true for any two congruent triangles. Their areas will be the same and their perimeters will also be the same. Now let's come to part 2. In part 2 we have to draw two triangles of equal areas such that the two triangles are not congruent. Now we know that the area of a triangle, the formula for the area of a triangle is half into base into height. So what we can do is we can draw two triangles with the same base length but unequal heights, so that same base and same height but different shape, so that the two triangles have equal areas but they're not congruent. So let me show you how we can do this. Okay, so let's first draw a triangle ABC. Let's take a base length of 5 units, so B, and I'm going to take C 5 units away here. And now let's take A such that the altitude of triangle ABC is 3 units from A to BC. Okay, so this distance here, let me highlight this distance I have taken as 3 units. Okay, now let's join the vertices of the triangle. So we have A to B and C. So this is our first triangle, triangle ABC. Now we will draw another triangle PQR with the same base. The base was 5 units and the same altitude, the same height 3, but in a different shape. Okay, so let's take P or Q here, and let's take R 5 units away, so that QR is equal to BC. So QR is 5. And now let's take point P here, let's say, such that the altitude from P, the height from P measured from the side QR, will also be equal to 3 units. And now if we join the vertices of PQR, we will get this triangle PQR, this triangle. Okay, so this triangle also has a base of 5 units and a height of 3 units. So let's write the areas. So the area of triangle ABC will be half into base 5 into 3. So half into 15 or 7.5 square units. And the area of triangle PQR will be half into base into height. So half into 5 into 3, because the height is 3. So half into 5 into 3 is 7.5 square units again. So the two triangles have the exact same area, but we can see that these two triangles are not congruent. They have completely different shapes. So this is an example of two triangles with the same areas, but which are not congruent. And in general, because the side lengths will be different, so the two side lengths, so BC and QR are equal. AB and PQ are also equal, coincidentally, in this example, but AC and PR are not equal for these two triangles. So this side and this side we can see are unequal. So in general, the perimeter of triangle ABC and the perimeter of triangle PQR will be different. So when we have two non-congruent triangles with the same area, their perimeters will in general be different. Okay, so the perimeters are in general different. Okay, so this is the relationship between the perimeters. So let's recap what we saw. So in the first part, we to draw two triangles of equal areas such that they are congruent, we simply drew any two congruent triangles and they will have the exact same area as well as perimeter. And for the second part, to draw two triangles of equal areas which are not congruent, we drew two triangles with the same base length, the same height, but different shape, and we got the same area. And in general, we observed that the perimeters will be different for the two triangles. So this completes question number 7.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.